Hello friends, today's question. In the figure, a ladder of mass m is leaning against a wall. It is in static equilibrium, making an angle theta with the horizontal floor. The coefficient of friction between the wall and the ladder is mu1, and that between the floor and the ladder is mu2. The normal direction of the wall on the ladder is n1 and that of the floor is n2. So if the ladder is about to slip, then we have to find out all the related answers to it. So this is the ladder, and mu1 and mu2 are the coefficient of frictions. So let us draw the various forces which will be acting on it. So this will be our mg, and we are going to, normal is already given, that wall is n1, so this is the normal n1, and here there will be normal n2, and we are going to have frictional forces in this direction. Let us suppose that is Fr2, and in this direction let us suppose that is Fr1. So we can say that our Fr1 is equal to mu1 into n1, and sorry, this is Fr1, and Fr2 is equal to mu2 into nr2. So it is said that it is a static equilibrium. So for the ladder rather, to be in horizontal equilibrium, for the ladder to be in horizontal equilibrium, we can write the equation as n1 is equal to Fr2, n1 and Fr2. So we can say n1 is equal to Fr2, or Fr2 we already know is mu2 n2. So from here we can say that n1 is equal to mu2 n2. And similarly we can say for vertical equilibrium, and for vertical there are three forces, n2, mg and Fr1. So mg is in downward direction, n2 and Fr in upward direction. So for the equilibrium we can say n2 plus Fr1 will be equal to mg, and we already know Fr1 is mu1 n1. We substitute it here, we get n2 plus mu1 n1 is equal to mg. And let us call this equation 1. So from equation 1 we can say that n2 is equal to n1 divided by mu2. From equation 1 we can say that n2 is equal to n1 divided by mu2. Let us call this equation 2. So therefore the equation 2 comes out. Therefore from equation 2 we get n1 upon mu2 plus mu1 n1 is equal to mg. Taking n1 as common, so we get n1, and this will be 1 plus mu1 mu2 divided by mu2 is equal to mg. Therefore, the normal n1 will be equal to mg mu2 divided by 1 plus mu1 mu2. And we can also find out our n2. So n2 is equal to n1 divided by mu2. So we get this as 1 upon mu2 mg mu2 1 plus mu1 mu2, and mu2 cancels out, so we get normal n2 is equal to mg divided by 1 plus mu1 mu2. So these are the values of the two normals. And next it is said that if the ladder is about to slip, we can say that when mu1 is equal to 0, you can say when mu1 is equal to 0, it will try to pivot. Okay, this is point P, and let us call this as point Q. So let me draw it here. This is point P and this is point Q, and let us suppose the total length is given as L, and this angle is theta, and we have this as mg. This is O. So when mu1 is equal to 0, we can find out the torque about point P. Therefore, torque about point P, it can be written as mg multiplied by this distance, and that will be L by 2 and cos of theta, because this distance will be L by 2, so this will be L by 2 cos of theta. L by 2 cos of theta is equal to n1 multiplied by this distance, that is L sine of theta. L cancelled out with L. So from here we can say that our n1 tangent of theta is equal to mg by 2, or we can say that our n normal will be equal to mg by 2 cot of theta. So this completes the question. Thank you.